So, good afternoon, everyone. And this talk is mostly on the hardware aspects of our Indian participation with SKA. Mainly, there are two areas, which is one is about the RF, and the other one is about the digital hardware packages. So we have moved a long way since our earlier ASI meetings. Currently, we have definite areas to work for the SKA. The two areas are actually one of the two nicest areas, and also associating India with two different telescopes. One is the SKA mid telescope, which is connecting us through the RF hardware production in India. And the second one is a digital hardware, which connects us with the SKA low telescope, which will be in Australia. In the case of the RF hardware, India has been given allocation to build, produce a good number of band 1 feed for the SK mid telescopes. This involves an RF electronics and also the RF structures of the feed and testing them and incorporating the finished product for the telescope, delivering the finished product for the telescope. And we do expect a large amount of Indian industry participation. And we also anticipate quite a lot of expert guidance will be available to the industry members through 11 team members from the Indian SKA India institutions. The second area of work is the digital hardware that is related to the tile processing module. This is a digitizer module of the SKA low. This is one of the larger participation from India in producing and delivering this product for the SKA low station beamforming. And once again, the work involves not just making the hardware, but also involvement in testing and characterizing them and delivering them to the telescope group. And Indian industry will be heavily involved. The activities involve printed circuit board design and assembly, integration, test. There is an echo, sorry. Is someone's audio?
I'll just see if I can mute the others. Go ahead.
Yeah. Just a second. Sorry.
I think
Sorry, I'm
Prabu,
just getting.
everybody else is muted now. So you think
Okay.
you can go ahead? Are you still getting an
Is
echo?
my screen? No,
Yeah.
fine. Yeah, I think there is a mild echo, but I think it should be okay probably. If you are hearing okay, then I'll go ahead. I think. Oh,
Yes.
this is
At
fine
least
now.
I'm able to hear you okay without any
Okay, no.
significant corruption.
Okay, no problem. Thanks. So this work also again will be guided through the relevant Indian Institute members who have expertise in the particular area of work. So industry will be heavily involved again in delivering this particular hardware for the SK low. So going further, coming back to the RF hardware, this is for the mid-frequency telescope. The telescope will be located in the Karoo region of the South Africa. There will be 197 Gregorian antennas. Each of them is about 15-meter class type. The telescope themselves are located on a large region spanning about 200 kilometers, and with the core being around 2 kilometers diameter area. So the feeds are fitted into the telescope in three different packages. They will be the band 1 feed, which India will be involved, covers a frequency range of 350 megahertz to 1.05 gigahertz. It's covering about a 3 to 1 fractional bandwidth. The other two feeds are band 2 and band 3 to 6. Those two packages are built by other members, and some of them are not yet being designed fully. So our focus is on band 1, which covers 350 to 1.05 gigahertz, 350 megahertz to 1.05 gigahertz. The feed itself looks something similar, something like what is shown on the right-hand side, and they form a massive 1 meter 1.5 meter tall and about 1.3 meter wide metallic structures. And these are quad rigid feed horns and fitted with electronics, RF electronics, which would produce the RF to fiber output at the far end of the electronic circuit, which is shown in the right side. So there are two stages of LNA, and the electronics also incorporate calibration, control, and monitoring. And finally, the RF comes out on fiber, and there's a power supply goes in, and that's the kind of electronics package that comes, that the Indian members will be building, and industry will be heavily involved in actually producing the mechanical structures and also assembling the electronics, and possibly also be involved in doing a lot of testing and in delivering the product as a final packaged unit for the mid telescope. So this is one of the areas that India is very much be involved and contributing to the SKA mid telescope in the South Africa. And going further, I am moving to the second part, which is the digital hardware, which is the tile processing module. And this is for the low frequency telescope located in Western Australia. The telescope itself is not new to us. We have done earlier work for this, the precursor telescope that is located in the same site. The Indian industry was heavily involved in building this electronics, especially in manufacturing, fabricating the PCB, assembling the components. And so we do have some previous experience with the same site where the scale low will be built. So currently what we are going to do for the scale low is actually building digitizers for the 131,000 antennas. India will be involved in at least 40% of the electronics for this number of antennas. So the telescope itself is a very novel structure, a log periodic antenna structure, which has got evolved through 4 different design stages. And the antennas are optimized to look at least 500 different directions simultaneously to enable enormous survey speed. And it covers about 50 to 350 megahertz operating range. The telescope site is very unique it's one of the very radio quietest place on Earth. So coming back to the digital hardware, where it is located and what we will be building. What is shown on the left is how the antennas will be organized. Each one of those log periodic antennas shown on the left will be digitized using a digital modules that are shown on the top. So there will be 132,000 analog to digital conversion units, which are supported by the FPGA hard located in the same printer circuit board. They will be assembled to form station packages, digitizer station modules, and there will be 512 such stations to cover the 131,000 antennas. It's one of the enormously large number of digital hardware pieces ever deployed on the field. Imagine the whole thing is spread around 40 kilometers, and these electronics will be digitizing such a large number of antenna outputs. And this hardware will be a good part of it. About 40% of the hardware required for the 131,000 antennas will be produced in India, and they will be fabricated, they will be assembled, they will be characterized, and they will be delivered as a finished finished entity to the scale O group. So our role basically involved in producing sizable number of these tile processing modules, advanced testing of the TPMs, and this work cannot be done unless the Indian industry can actually raise to the level at which what the quality that will be required for that large number of electronic hardware that is going to be deployed in the desert. So there will be a very good amount of expert guidance that will be required for the industry that we hope we will be able to provide from the relevant members from the SK India institutions. So this is more or less what we have for the hardware. And to summarize, so India will be involved in producing 2 major hardware packages for the SKA, and one of them is the RF hardware, which is for the SKA mid telescope. And this covers a band 1 feed, about 10 to 15% of the 197 antennas. The parts will be possibly get built in India, and the production, testing, and supply of sizable number of these band 1 feed will involve in the Indian industry, and guided by relevant members from the SK India institutions. So also the second part is the digital hardware. About 40% of the 131,000 digitizers will be built in India, which could amount to close to 4,000 digital hardware boards and a system, uh, integrated system test, and also characterizing them and so on. And this is impossible to again do it without the industry support. However, there will be a relevant uh, good number of Indian institutes have the relevant domain knowledge specifically required for characterizing the both RF hardware and the digital hardware are available, and they will be in supporting, reinforcing the industry in terms of providing knowledges and so on. So that are the two packages, and here I end my talk. And we do have an afternoon session at 4 o'clock, where we will be briefing a little bit more on some of the details and timelines and how we plan to achieve this, and also especially taking our experiences from the MWA and the previous work that we have done in the country. Thank you,
Okay,
everyone.
thanks. Thank you, Prabhu. And you've brought us back almost on time with the original schedule. And let's see if there are questions or comments on this part of the presentation relating to the hardware work packages that India will be participating in. Are there any questions from the members joining in on the Zoom link or on the YouTube link? Okay, I don't see. I don't see any questions. Yeah, I see one now on the YouTube link from Hariharan Krishnan, which says, is there any contribution to SKA digital firmware from the Indian side?
Yeah, thanks. Can I take the question, Yashwant?
Yes, please go ahead.
Yeah, thanks for asking that question, Hariharan. I think this is a very good question. One of the major areas where the industry could participate is the digital hardware that I have talked to. Another area where some of the members are involved is related to the firmware, some features of the firmware, which we hope will be a design effort, not a production effort, mainly because the firmware effort is relatively a smaller fraction. And once the firmware is developed, and it's more or less is available for the entire hardware. So due to this reason, it's a small fraction. We are not completely ruling out there may be an industry involvement, but there is a minor level of contribution from India for the firmware.
Okay. I don't see any further questions from either the Zoom participants or from the YouTube participation. In which case,
Yashwant, there is one new question on the YouTube.
okay,
What are the next steps immediately out of the TPM output?
TPM output.
Yeah, thanks, Yogesh. Is this question comes from an industry or from the
This
some
comes
some?
from Kiran Mehta.
Okay, Kiran Mehta. Okay,
Yeah.
thanks. Kiran Mehta, I think after the TPM, I will just go scroll down back to a slide where this diagram. I think it is switched to the slide where the station correlator and beamformer. Is it visible? I believe. Yeah. Okay. The TPM outputs are actually the station beams. They are actually not formed inside the TPMs. Tile processing module, group of tile processing modules are cascaded in a daisy chain mode, so that about 16 of the boards, which are shown on the top, work together to form the station beams. And those station beams are sent to what is known as a beamformer correlator, where they are further the subsequent beams, the 500 beams get formed over here. And also the correlation takes place in the blue box, which is shown here. So the unit is called beamformer correlator or correlator beamformer. And that splits the output to two other sections. One is called the imaging. The other one is the non-imaging, which is mainly the pulsar search and transient study pipeline. So the imaging and non-imaging outputs go down to the global distribution subsequently. So I hope this answered the question.
Yes, I think it does. And okay, I don't see any further questions. And so that brings us to a more general discussion on these topics. So we heard two talks clearly outlining the nature of the work for both software and hardware-based work packages where India is involved in. And just want to see if there are any further queries. So I see there is, meanwhile, another question by Sonia Ghosh. What processes will be involved in TPM?
So TPM is basically a digitizer. Every antenna element is digitized, and there is a filter bank, which is basically an improved version of the Fourier transform FFT polyphase filter. Subsequently, 16 antenna element outputs are combined to form tile beams. So the TPM is a module which is digitizer, spectral decomposition, followed by tile beam forming. Tile is 16 antenna elements. Tile is formed out of 16 antenna elements. And the last stage of the TPM is a station beam forming. So there are 4 distinct units. And there are other functional aspects which are like RFI flagging and transient buffering and few other features that are useful. So it's a digital FPGA based processing engine, and that use one of the most modern FPGAs.
Okay, there is a question from Kiran Mehta, which is about the difference between imaging versus non-imaging data. Maybe Prabu, do you want to explain that very quickly?
Yeah, I'll quickly tell. Imaging data, basically we are recording the visibilities, the correlation between the different antenna pairs. If there are 512 stations, each pair, the antenna 1 versus 2, 1 versus 3, and so on, all the way up to 512, and for the 2 polarizations are produced. And it is in a way a low time resolution correlation products. Non-imaging is just a name, happen to be non-imaging. It's basically a time domain data, which means high time resolution of the incoming data is preserved. And usually the processing is done through a phased array output of the 512 stations. And there are about 500 different phased array outputs will be simultaneously processed there. I hope this answer. Thanks for the question.